All right, so we have started chapter 19 talking about confidence intervals for proportions. All right, so this is your first interaction with confidence intervals, your very first one. All right, I'm so excited for you guys. All right, we have a local newspaper polls random sample of 330 voters, finding that 144 say they're going to vote yes on the upcoming school budget. Let's create a 95% confidence level or interval for what would happen if everyone answered this question. Okay, if we were able to have the time and money to find everyone. Okay, so the first thing you want to do is make your assumptions. Okay, so who wants to give it a try for the independence assumption? Who wants to raise their hand? Give it a shot. What statement are you going to write to assume independence? All right, Ureth.
One person's vote on the upcoming school budget won't affect another person.
Perfect. So one person, I'm going to tweak it a little bit, but yours is totally fine, Ureth. One person voting yes will not affect anyone else. Okay, so that's what we're thinking. That's what we're assuming. And I don't really have any reason to believe that this is in violation here, right? Someone voting yes is not going to impact someone else voting yes. Okay, let's check some conditions. Let's do the randomization condition. Okay, so in the problem, did it say anything about randomness for that sample of 330 voters? It did. Awesome. Yes, thank you. So it says in the problem that it's a random sample of 330 voters. Awesome. That's super nice. Thank you, problem. All right. The last condition for independence is the 10% condition. All right. This is the same condition we've been doing for a while now. All right. You're going to take 30. I don't know, I said 30. 330 and multiply it by 10. So what is 330 times 10?
3,300.
Very good. 3,300. All right. So are there more than 3,300 voters in this area? Do I know? I don't, but I would just write, as long as there is more than 3,300 voters, our sample size is not too large. Zoom in for you. So as long as there is more or are more, you guys know English better than I do. As long as there are more, yeah, is that what we're going with? I know where my faults lie, my weaknesses. As long as there are more than 3,300 voters. Is it because it's voters plural? Is that why? Right, if as long as there is more than one voter. See, right? AP English, I never took it. Our sample size is not too large. That's why I'm a math teacher. I took AP my junior year for English. I was like, never again. Okay. My dad was like, you're going to regret that. No, I'm not. Okay. What about the other assumption? The sample size assumption. Okay, who wants to raise their hand and give this a shot? Someone besides Ureth. Okay, Leslie, yes.
330 voters is a large enough sample.
Perfect. 330 voters is a large enough sample. Awesome. Nice work. Okay. Now, because this is talking about proportions, right? We only have two answers here, yes or no, so it's a proportion. We are going to do the success failure condition, which we did last week on Tuesday. Okay? So this is n times p and n times q. Now, when the problem is written in this way, I actually don't use n times p and n times q. Does anyone know why I don't need to use n times p and n times q right in this problem, the way they've written it? Anyone see why? That is going to be later on when we do it. They gave me what? They gave me what? Yeah, and that would be what? That would be the successes, right? So my successes is 144. And then if you subtract 144 from 330, you should be able to get the number of failures. Who says no, or who's going to vote no on the upcoming school budget? 186? Sounds good. You got the calculator. Love it. Anyone want to confirm, Leslie? 330 minus 144 is 186. Boom. Excellent. All right. Now, what am I checking with these two numbers? That they're what? That they're 10 or more. Are those numbers 10 or more? Excellent. So I'm going to write both numbers are 10 or more. So 330 voters is large enough. Whew, man, this is fun. Okay, now, hopefully you've got a space for one more sentence. All right, we've never written this sentence before, so I'm going to go slow when I write it. All right, I'm going to go ahead and just write and creep into my next slide. So if you need to, creep into the next slide, or you can do it in the space between slides. All right, wherever you are, just write this. This is new, okay? All right, so I'm going to do like, just so you know this is new. We've never done it, okay? The conditions have been satisfied. So I will use the normal model to run a one proportion z interval. All right, I know my handwriting is not great, so I'll say it again. The conditions have been satisfied, so I will use the normal model to run a one proportion z interval. You need to write this. Yeah, I thought I want to make this stress this, that obviously you're going to write all this stuff with the assumptions and conditions. We've done all that. We've never written this statement. So this statement, you're going to do this pretty much every time we do something new in this class from now until you graduate. There's going to be a statement like this associated with it. Right? I'm going to teach you how to do other intervals. I'm going to teach you how to do something called a hypothesis test. Right? So you'll have the same sentence. It'll just say, I'm going to do something else. All right, you're telling anyone reading this, here's what's coming. Okay. Any questions so far? Because we're about to get to like the actual math. Any questions so far on this process? Make assumptions, check conditions, write the statement. No, everybody good? Awesome. Let's do the math. Okay, so what I noticed is that I'm going to use a lowercase x for the number of successes. So how many people said they're going to vote yes in the upcoming school budget? 144. Okay, then I'm going to write n for my sample size. How many total people were asked? 330. Then I'm going to do p hat. Why did I write p hat? Sample proportion, right? This is a sample of people, so it's p hat, not p. All right, and p hat is 144 over 330. So take your calculator when you get a chance and do 144 over 330. That's p hat. 0.436. Excellent. All right, so we have found p hat. Now I'm going to use the formula, all right, for a confidence interval with proportions. So the formula, I'll write it down for you, is p hat plus or minus z star times the standard error of p hat. And again, you'll get that, all right, but you know, obviously I've done this for a long time, so I just have it memorized. It's Just you do it so much, you remember it. All right, so we already know p hat, right? What is p hat? 0.436 plus or minus. Now, do you guys see Z star? All right, Z star is going to come from your confidence level. And in the problem, it said to use a 95% confidence level. Okay? So that means I'm going to use 1.96. The way I memorized it in high school was 95, 96. So 1.96. That's how I memorized it. Okay? So 1.96 times. Now, the standard error of p hat is a formula. Okay? I'll write it over here. The standard error of p hat is the square root of p hat times q hat over n. I'll put a little like clouds around it. Okay? So I'm going to do the square root of 0.436 times whatever 1 minus 0.436 is. 0.564 over 330. You got it. Whew. We're almost there. So close. Okay? So when I get to this point, and I've shown all of my work, in the calculator, I'm going to do everything that's to the right of the plus or minus. Okay? Because everything that's to the right of the plus or minus is called the margin of error. So basically, if I asked any of you, what do you think is going to be the proportion for all of the people who vote that say yes to the upcoming school budget? What are you going to say is the answer? What do you think it is? Let me do it again. What do you think is the percentage of all voters who are going to say yes to the upcoming school budget? The only percentage we have up here. It hasn't been written as a percentage, but the only percentage for the sample was 0.436. So right now, do I think it's anything other than this? No, I think it's this. Right? Do I know what it is? I don't. All I know is that this is from a sample of voters. If that sample is representative of all voters, then I think this is going to be fine. But because I don't know for sure, I have this leeway here, this margin of error, where I'm going to go up a little bit and down a little bit, and I think that interval is going to capture what it really is. Okay? So, did anyone calculate all of that, the 1.96 times that radical? 0.054? Yes, confirm? Nice. Okay, so now you're going to write in parentheses the lower one and the upper one. So go ahead and do 0.436 minus 0.054. And then do 0.436 plus 0.054. Okay, so here's the last statement you're going to write. All right, the very last statement. Is everybody good on how I got? I know this is amazing, right? Is everybody good on how I got this part here? Okay. The last statement is this: I am 95% confident that the true proportion of all voters who will vote yes to the upcoming school budget is between 38.2% and 49.0%. Whew, man, that was fun. That's it. Now, while you're kind of thinking, wow, that was a lot of work to do, totally understand, that's a lot of stuff. I want to do my best to try to explain what this means. Okay? Because we don't know, right? Let's say there's 100,000 people who live in this town. Okay? Or let's do this. 100,000 voters. Right? Let's say there's 100,000 voters that are in this town. I don't have the time or the money to find out what all 100,000 think about this topic. So we have this random sample that's supposed to be a good representation. When we make this confidence interval is based on what, guys? What is the only thing it's based on? It's based on the results from the sample. So all the numbers I just calculated is based on 144 out of 330. Everything is based on that. Okay? So when I'm saying that I am 95% confident that the true proportion for all 100,000 voters is between these two numbers, I'm saying I don't know what it is. Okay? We either are going to capture it or we're not. Will we ever know if we capture it? No, I'm not going to know if we capture it. All right? Personally, no. I'm not going to get the results for the voting on this. Okay? But someone could. Someone could get the results when the voting is done and see if our confidence interval caught it. All right? I'm going to talk next week when the boys are back what this 95% means. All right? How do we interpret when we change this number? Yes?